Welcome to lab. We are going to have a short lecture on measurements to get us going for the measurements lab. This is kind of a separate topic. It kind of has to do with what we were covering in lecture, but it's really specific to what we cover in lab because it's how to make a measurement, which is what we would practice in lab. So our purpose here is to learn how to make and record measurements of length, mass, volume, and temperature, and to understand that every measurement has an associated error, and that these errors limit the number of digits that appear in a measurement. Okay, so this is really useful when we are actually going to go and measure things, whether this is length or volume, which are really the two that we will actually measure in lab. And it's going to make sure that we record our measurements to the right number of digits. Okay, and this is really important because it shows us the accuracy of our measurements. So in the measurements lab that you guys are going to do in just a minute here, you are going to need to record the measurements to the right number of digits, especially in the first couple of pages to get the practice, but also when you're measuring like the length of your cardboard and things like that, the volume of your liquid. You need to have the right number of digits when you record these measurements. So our measured numbers, right, are the ones that we're looking at. We talked in lecture about exact numbers versus measured numbers. Exact numbers are things that you can count. Like I have 3 cats, right? I don't have 3.2 cats because that's not possible, right? I have exactly 3 cats, which is a lot. But when you have measured numbers, like reporting the length or reporting a volume, you can only measure it as well as your measuring device, okay? So to measure the length of an object, like this piece of wood below, we have our centimeter ruler. And the purpose, right, or the way that we're going to go about this is we are going to observe the numerical values of the marked lines. So if we look, right, there's 1, 2, 3, 4, 5. And we are going to estimate the last digit by visually dividing the space between the smallest and marked lines. So this object is between 4 and 5, right? Nobody is going to debate that with us. The length of this piece of wood is somewhere between 4 and 5. And you're going to estimate where it's at between 4 and 5. We're going to estimate 1 digit past what we have a line for, right? We have a line for 4, we have a line for 5, so we're going to estimate, okay, it's going to be 4 point something, right? And that something is going to be different based on, how people see it. Most people on this one are going to guess that it's going to be 4.5 because it looks about halfway between the 4 and the 5. But you could also say maybe 4.4 or 4.6, right? Because that last digit is an estimate. There's no way of knowing if you're right or wrong because there's no lines there. So somebody saying 4.4 or 4.6, all of those, even 4.3 or 4.7, all of those would be acceptable answers because this last digit is a guess, an estimate, right? But you need to have, right, this 4, the fact that it's between the 4 and the 5, that's not debatable. The last digit is an estimate. We have a guess. We have a line for 4, we have a line for 5, so we're going to estimate 4 point something. And again, all of these answers can't be correct unless you have a unit with them. Okay. Like I said, most people here would say 4.5, but the other answers would be acceptable as well. So a digit that has to be estimated is called uncertain. And any measurement that we make, or even that a computer makes or electronic balance makes, always has some degree of uncertainty because measurements are performed with instruments and no instrument can read to an infinite number of decimal places. We're always going to have some amount of uncertainty in our measurement. So this is where we get into those sig fig rules that we talk about in lecture, okay? So, like I was talking about earlier, this one is between 4 and 5. So we say, okay, if it's between 4 and 5, we're going to estimate 1 more digit. Okay, so that's going to make this 4.5 centimeters. Let's try another one. Now we found a better ruler, which is great. This one is marked every 0.1 centimeters. So now if we look at the same piece of wood that was between 4 and 5, we now have more things. So this is now 4.1, 0.2, 0.3, etc., right? We have a line every 0.1 centimeters. So now we can see that this wood is somewhere between 4.5 and 4.6. Okay, so again, we have a line for 4.5. We have a line for 4.6, and it looks like the wood falls somewhere in between there. Okay, so now, since we have a line for 4.5, we have a line for 4.6, we're going to estimate one digit past that. So it's going to be 4.5 something. Okay, so in this case, it looks like it's about halfway between 4.5 and 4.6, so we're going to estimate this as 4.55. But you could have written 4.54 or 4.56, right? Because again, that last digit is always an estimate. We are always taking a guess because we don't know exactly. We know it's between 4.5 and 4.6, but we don't know where exactly it is between it. Okay. Sometimes you will have objects that line up exactly, right? Like this one looks like it's exactly on the 3, okay? But you can't just say that it's 3 centimeters because we have a line for 3, right? We have a line for 3 and a line for 4. So we're always going to estimate one digit past what we have a line for. So if we think it is exactly on the 3, which it appears that it is, then we're going to say, okay, it's 3.0 centimeters. That's telling us, no, I think it's really exactly 3, okay? Again, we have a line for 3, we have a line for 4, so we're going to estimate one digit past what we have a line for. So let's try this one. This is just to get a little bit of practice doing these estimates, right? And I know that this looks a little weird. These are lines. Like this is 8, this is 8.5, this is 9, this is 9.5, this is 10, right? So it looks like we have lines every 0.1. Okay, so I want to know what is the length of the red line. So I'll give you a second, and then I'll let you know the answer. Okay, so thinking about this, right, we have, in looking at the red line, it looks like it is between the 9 and the 9.1. So it's somewhere between 9.0 and 9.1, which means it needs to be 9.0 something, right? Because we're always going to estimate one digit past what we have a line for. So now we know that number 1 is out, right? 2 reasons. 1, it doesn't look like it's exactly on 9.0. It looks like it's a little bit past that. 2, it has the wrong number of digits. We have a line for 9.0, so we can't have 9.0 as an answer. If we thought it was exactly on that line, it could have been 9.00, but again, it doesn't look like that's the case. It looks like it's a little bit past that, so either way, that's a bad answer. So now the question is this 9.03 or 9.04? The answer is that it's both, or neither, right? Either one could be correct because that last digit is an estimate. It's between 9.0 and 9.1. So whether you put 9.03 or 9.04, either one is correct because that last digit is an estimate, and it's going to be based on, who looks at it. So here you go. This is the answer. That's what it's saying. Could be either 9.03 or 9.04. That estimated digit may be slightly different based on who reads it, but both digits both answers are acceptable because it has the right number of digits. And that's the end. In this measurements lab, the most important thing is to figure out how many digits should I be reporting. That's like the number one thing that trips people up in this lab. And a lot of people struggle with this lab for that reason. They are like, how many digits should my answer really have? If you get into that, come back and watch this lecture again. See if you can figure out, okay, what do I have a line for? Like, do I have a line for 3.0 and 3.1? Then it's got to be 3.0 something, right? You're always going to estimate one digit past what you have a line for. So that is the number one thing that people struggle with in this first lab, which is why I made a video for it. So good luck, and please let me know if you have any questions. Otherwise, enjoy the lab.